Hi, Honors Trig Pre-Calc. We have just a few short notes to take to Intro Section 3.5, which is equation solving and modeling. Some helpful tips to remember about logarithms. These are things that we know, but good reminders. If a to the x is equal to a to the y, if the bases of two exponentials are the same, then we can say x is equal to y. And we can say the same thing for logs, right? If log base b of x is equal to log base b of y, if the bases of the logarithms are the same, then we can say x equals y, right? Those are two things we know. We also know, let's go with log base m of n is equal to p. I can change that from logarithmic to exponential. M to the p power is equal to n. And last but not least, just of our reminders, if I have log base b of b to the x power, well, this base is the same as the base of the log, excuse me, is same as the base of the exponent. So these are going to cancel and we are left with just x. Or on the reverse, we could say a to the log base a of x. Log of the exponential is the same as the log of the base of the log, oh my gosh, and that's equal to x. So here are our reminder facts that are very important in this section, just some properties that we know, along with our properties of condensing and expanding. So let's talk about some general strategies for solving exponential and logarithmic equations. Step one is going to be to isolate the expression with the variable. And step two, which is kind of potentially a step one type deal, is to swap between exponential and logarithmic as needed. Let me give you an example of what these steps might look like. If I had log base 7 of x plus 3 is equal to 15, well, that first step there, the isolate the expression with the variable, oh, you can't see that. Isolate the expression with the variable, well, we'd start by moving the 3 over, right? Get the thing that has the x all by itself. So log base 7 is equal to 12. That's kind of this first piece. And then this is in log form. Oops, I forgot. Log base 7 of x. This is in log form, but we can't solve it this way, so we change it to an exponential. 7 to the 12th is equal to x, and we have our answer. The next kind of general strategies or steps is to write exponentials with the same base as possible, if possible. Write exponentials with the same base, if possible. This is a tip. All of these are really tips. They're not really steps, they're just ideas. So if I have, let's say, 1 over 2 to the x is equal to 8, well, I know I can write 8 as 2 cubed, and I really have 2 to the negative x there. So I'm writing these as the same base, and now I know negative x is equal to 3, or x is equal to negative 3. Another general tip is, if needed, condense logarithmic expressions. So if you have a bunch of logs, make them all 1. If I had something like log base 3 of x plus log base 3 of, let's go, x plus 1 is equal to 4. Well, I want to condense this left side. I know when I have addition on the outside of the logs, I can multiply the things within. So log base 3 of x squared plus x is equal to 4, right? X times x plus 1. And now I'm in log form. I can't do a whole lot. I would then change it to exponential. 3 to the 4th is equal to x squared plus x, and I can solve that. And then the last tip here for solving is you always, always, always want to check for extraneous solutions. Check for extraneous solutions. Or, as a reminder, solutions that come from the way we solve, but that are not actual solutions. And the big thing we want to remember is that I cannot take the log of a negative number. Log base 3 of x is equal to 4. Well, let's think about this. If we think of our swirl, 3 to the 4th power is equal to x. X will never, whatever 3 to the 4th power is, it doesn't matter. This thing will never be equal to 0. X will never be equal to 0. And I can say very confidently, x is going to be positive. So both of those things here are going to be taken into this idea that we cannot plug a negative number into a logarithm, or the thing we get inside the log cannot be negative. So for example, if I have log of x minus 4 and I solve my equation and let's say one of the solutions I get is x equals 3, this would be an extraneous solution. Why? If I plug it in, log of 3 minus 4, I would have log of negative 1. This can't happen. I cannot take the log of a negative number. So check for extraneous solutions. The other thing I want to show you before class is Newton's law of cooling. Not necessarily this example yet, we'll do that together, but I want to look at this formula because it's something we're going to see a couple times. T is referring to temperature, capital T. Lowercase t is time. T of m is the temperature of the medium, which means the temperature of the medium is the thing that the object is in. So this can either be air, it can be water. T0, hopefully not surprisingly, is the initial temperature. And then K is going to be some constant that we would have to solve for. So we will do an example using this, but I wanted you to have the formula ahead of time. Have a great rest of your weekend.